LangGraph implements a hierarchical state management system through nested StateGraph instances, enabling modular composition of computational workflows while maintaining isolated state scopes. The framework's streaming mechanism surfaces real-time updates from both parent and child graphs, with configurable granularity at the node level. We're about to examine how a subgraph with shared state keys integrates into a parent graph, with streaming configured to emit updates from nested execution paths. The code demonstrates state propagation between graph layers, and the use of the subgraphs equals true parameter to include nested outputs in the stream.
From LangGraph, graph import start StateGraph. From typing import type dict. Hash define subgraph. Class subgraph state type dict. Foo, SDR hash note that this key is shared with the parent graph state. Bar, SDR. Def subgraph node 1 state, subgraph state. Return bar, bar. Def subgraph node 2 state, subgraph state. Return foo, state foo plus state bar. Subgraph builder equals state graph subgraph state. Subgraph builder, add node subgraph node 1. Subgraph builder, add node subgraph node 2. Subgraph builder, add edge start, subgraph node 1. Subgraph builder, add edge subgraph node 1, subgraph node 2. Subgraph equals subgraph builder, compile. Hash define parent graph. Class parent state type dict. Foo, SDR. Def node 1 state, parent state. Return foo, hi plus state foo. Builder, state graph parent state. Builder add node node, node 1. Builder add node node, subgraph. Builder add edge start, node 1. Builder add edge node 1, node 2. Graph equals builder compile. For chunk and graph stream. Foo, foo. Stream mode equals updates. Hash set subgraphs equals true to stream outputs from subgraphs. Subgraphs equals true. Print chunk.
This code demonstrates how to construct and stream outputs from nested subgraphs in LangGraph, a crucial pattern for building modular and observable workflows. The example shows a parent graph that incorporates a subgraph as one of its nodes, with both graphs sharing a common state key, foo. The subgraph is built independently with its own state definition and nodes, then compiled and added to the parent graph as a single node. This composition pattern enables hierarchical workflow design while maintaining state isolation where needed. The streaming mechanism is configured with stream mode equals updates and subgraphs equals true, which produces a detailed output stream showing updates from both the parent graph and nested subgraph. Each chunk in the stream includes namespace information that identifies whether it originated from the parent graph or a specific subgraph invocation. This approach provides fine-grained observability into complex workflows, allowing developers to track state changes across different levels of abstraction. The trade-off is increased output verbosity, which may require filtering in production scenarios. The design choice to use shared state keys, foo, between parent and subgraph enables seamless data passing without explicit parameter mapping. However, this tight coupling means state modifications in the subgraph directly affect the parent graph state. The streaming configuration demonstrates how LangGraph handles nested execution contexts, with each subgraph invocation getting a unique task ID that appears in the namespace tuple. This pattern is particularly valuable for debugging complex workflows or building real-time monitoring systems where visibility into subgraph execution is required. Let's break it down.
From LangGraph, graph import start StateGraph.
Import start and StateGraph from the LangGraph graph module. Start is a constant representing the entry point of a graph, while StateGraph is a class for defining stateful workflows with nodes and edges.
From typing import type dict.
imports typed dict from the typing module, which enables creating dictionary types with predefined key-value type pairs for static type checking.
Class subgraph state type dict. Foo, SDR hash note that this key is shared with the parent graph state. Bar, SDR.
Defines a subgraph state class that inherits from typed dict, specifying a dictionary structure with two string fields, foo and bar. The comment indicates that the foo key is shared with the parent graph state, suggesting this subgraph state will interact with or extend the parent state structure.
Def subgraph node 1 state. Subgraph state.
Defines a function named subgraph node 1 that takes a single parameter state of type subgraph state. This function signature indicates it's designed to operate as a node within a subgraph, processing or transforming the provided state object. The implementation details of what it does with the state aren't visible in this segment.
Return bar. Bar.
Returns a dictionary with a single key bar, mapped to the string value bar.
Def subgraph node 2 state. Subgraph state. Return foo. State foo plus state bar.
Defines a function named subgraph node 2 that takes a subgraph state object as input. The function accesses the state's foo and bar values, adds them together, and returns a dictionary with the result stored under the key foo. This effectively updates the foo value in the state by combining it with bar.
Subgraph builder equals StateGraph subgraph state.
Creates a StateGraph instance named subgraph builder, using the subgraph state class as its state management type. This initializes a graph structure that will manage state transitions and node execution with the specified state schema.
Subgraph builder. Add node subgraph node 1.
Adds a node identified by subgraph node 1 to the graph being constructed by subgraph builder. This operation registers the node within the builder's internal structure, making it available for subsequent graph operations.
Subgraph builder. Add node subgraph node 2.
Adds a node identified by subgraph node 2 to the graph being constructed by subgraph builder. This operation registers the node within the builder's internal structure, making it part of the subgraph's topology.
Subgraph builder. Add edge start. Subgraph node 1.
Adds a directed edge from the start node to a node named subgraph node 1 in the graph being constructed by subgraph builder. This establishes a connection where execution can flow from the graph's entry point to the specified subgraph node.
Subgraph builder. Add edge subgraph node 1. Subgraph node 2.
Adds a directed edge from node subgraph node 1 to node subgraph node 2 in the subgraph being constructed by the subgraph builder. This establishes a dependency where subgraph node 2 will execute after subgraph node 1 in the workflow.
Subgraph equals subgraph builder. Compile.
Calls the compile method on the subgraph builder object, which processes the subgraph definition and returns a compiled subgraph ready for execution. The resulting compiled subgraph is then assigned to the variable subgraph. This is a standard build step that prepares the subgraph for use in the larger graph execution flow.
Class parent state type dict.
Defines a class parent state that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys and values. This establishes a type-safe container for state data, where each field's type can be explicitly declared when the class is fully defined.
Def node 1 state. Parent state. Return foo. Height plus state foo.
defines a function named node1 that takes a state parameter of type parent state. The function returns a dictionary with a key, foo, whose value is the string hi, concatenated with the value of state foo. This operation effectively prepends hi to the existing value of the foo key in the input state.
Builder, StateGraph parent state.
Creates a StateGraph instance using parent state as the state type. This initializes a graph structure where nodes will operate on and modify states of type parent state. The builder variable now holds this graph instance, ready for adding nodes and defining edges.
Builder add node 1.
Adds a node named node1 to the graph builder, associating it with the node1 function or object. This registers the node in the graph structure, making it available for execution and state updates during graph traversal. The node will be identified as node1 in the graph's topology.
Builder add node, subgraph.
Adds a node named node2 to the graph builder, where the node is implemented by the provided subgraph. This incorporates the subgraph's functionality as a single node in the parent graph structure.
Builder at edge start, node 1.
Adds a directed edge from the start node to node 1 in the graph being constructed by the builder. This establishes that node 1 will be the first node executed when the graph runs, as it's directly connected from the entry point.
Builder add edge node 1, node 2.
Adds a directed edge from node 1 to node 2 in the graph being constructed by the builder. This establishes a dependency where node 2 will execute after node 1 completes, defining the control flow between these two nodes in the workflow.
Graph equals builder compile.
Compiles the graph constructed by the builder into an executable graph object. This takes the graph definition created through the builder interface and produces a runnable graph instance that can be executed or streamed. The resulting graph variable holds this compiled graph ready for invocation.
For chunk and graph stream.
Iterates through each chunk in a streaming sequence from the graph. The stream method initiates a real-time data flow from the graph, yielding incremental updates or outputs as they become available. Each chunk represents a discrete unit of data emitted by the graph during its execution, allowing for progressive processing or display of results.
Stream mode equals updates.
Sets the streaming mode to updates, which configures the graph to stream state updates after each execution step. When multiple nodes run in the same step, their individual updates are streamed separately rather than batched together.
Hash set subgraphs equals true to stream outputs from subgraphs. Subgraphs equals true.
Sets the subgraphs parameter to true in a streaming configuration, enabling the streaming of outputs from nested subgraphs alongside the parent graph's outputs. This ensures that real-time updates from both the main graph and any contained subgraphs are included in the streamed results.
Print chunk.
Prints the value of the variable chunk to the standard output. This is a simple debugging or logging statement that displays the current content of chunk during execution. This example showcases LangGraph's hierarchical state management through nested StateGraph instances, where a subgraph with shared state keys integrates seamlessly into a parent graph. The key pattern here is modular composition with state propagation. The subgraph's foo key directly modifies the parent state, demonstrating tight coupling through shared state while maintaining isolated scopes for other keys. The streaming configuration with stream mode equals updates and subgraphs equals true provides fine-grained observability, emitting real-time updates from both parent and nested execution paths. Each chunk in the stream includes namespace information that distinguishes between parent and subgraph outputs, which is particularly valuable for debugging complex workflows. The trade-off is increased verbosity, which might require filtering in production. The design choice to use shared state keys enables seamless data passing without explicit parameter mapping. But this tight coupling means subgraph modifications directly affect the parent state. This pattern is powerful for building modular yet interconnected workflows, with the streaming mechanism offering crucial visibility into nested execution contexts.
The subgraph injects its bar into the parent's foo, only to watch it reappear as its own foo in the stream.